Have you ever looked at the inside of a tree trunk and noticed those rings and wondered what they actually mean? At first glance, tree rings might seem like a simple way to tell how old a tree is, but they're actually much more than that. Tree rings can tell a story about the tree's life, the environment it lived in, and even the conditions of the world around it. Today I'm going to talk about dendrochronology, which is the scientific study of tree rings and how scientists use these rings to learn about the past. In a way, a tree is like a natural record keeper. It quietly saves information in its trunk year after year, almost like a diary written by nature. However, in order to understand that story, we first need to know what tree rings actually are. Tree rings are the circles you see when you cut across the trunk of a tree. Most people know that rings can help estimate a tree's age, but each ring is also part of a larger record. In general, one ring represents 1 year of growth. That means if a tree has 50 rings, it is usually around 50 years old. But the rings do more than count time. They also show us how the tree grew during each of those years. You can think of rings like pages in a book or entries in a journal. Each one adds a small part of the story. Over time, those layers become a natural timeline of the tree's life. But how do those rings really form in the first place? Tree rings form because trees grow from the inside out. Just beneath the bark is a thin layer called vascular cambium. That layer works almost like a growth engine. It creates new cells that help the tree become wider each year. In the spring, when conditions are usually more favorable, the tree grows quickly and forms the so-called early wood. Early wood is made of a lighter and larger cell particles. Later in the year, growth slows down and the tree forms late wood, which is denser and tighter. Together, early and late wood make one ring. So a ring is really a combination of two different growth patterns from the same year. That is what makes tree rings so useful. They are not random lines, but a record of how the tree responds to each season. Now that we understand what tree rings are, let's look at how to actually read them, because this is where it becomes a little bit like solving a puzzle. If you look at this image, you'll notice that the rings form circles that start at the very center of the tree and move outward. The center point is where the tree first began growing. You can think of this as the tree's birth year. Every ring that forms after that represents 1 year of the tree's life. So to count the age of a tree, you can start in the middle and count each ring as you move outward toward the bark. Each light and dark part together counts as 1 year, not each line individually, but as one full band. For example, if you count 10 rings from the center to the outside, that means the tree is about 10 years old. Now, something important to notice is that in this image, is that not all rings are the same size. Some are wider and some are more narrow. The wider rings usually represent years when the tree had plenty of water and good growing conditions. The narrow rings show years when the tree struggled. Maybe there was a drought, less sunlight, less nourishment, whatever it may have been. So when scientists look at a tree like this, they're not just counting, but they're also interpreting. They're asking questions like, why was this year harder? What was happening in the environment at the time? On the right side of the image, you can also see how scientists sometimes take small core samples from a living tree instead of cutting it down. This tool pulls out a thin cylinder of wood, and that sample still contains all the rings in order. That allows scientists to count and study the rings without harming the tree or harming it on a smaller magnitude. So in a way, reading a tree ring is a combination of counting and storytelling. You're counting the years, but also learning what those years were like. Well, what do the rings tell us about the environment? This is where it becomes especially interesting, because as we've covered, they don't just tell us about the tree itself, but overarchingly about the environment around it. For example, narrow rings can mean that the tree had a difficult year, often because of drought or limited water. Wider rings will usually mean that the tree had a better growing condition, like enough rain and sunlight. Sometimes scars in the wood can show that the tree experienced a fire or some kind of injury. In extreme cases, a tree may even fail to form a clear ring if it was under too much stress. So, in a way, the tree is recording its own experience of the environment. It cannot obviously speak about it, but within the rings, it can tell us whether it was an easy or a difficult year. That is one reason scientists value tree rings so much. They preserve the environmental history in a living structure. And because tree rings store that kind of information, scientists can use them in all kinds of fields beyond just biology. Scientists study tree rings for several important reasons. One major one is using it to learn about past climates. Before modern weather records existed, tree rings helped scientists understand whether a period was wet, dry, hot, or maybe cold. Tree rings can also help date old buildings and wooden objects, which is especially useful in history and archaeology. If scientists know when a piece of wood was cut, they can learn more about when a building was built or when an object was made. Tree rings can thus even provide clues about past solar activity, which shows how closely the tree growth can be connected to a larger natural system. So tree rings are not just a biology topic. They connect to climate science, history, archaeology, and even potentially astronomy in some cases. They are great examples of how one simple natural pattern can help answer big scientific questions. This is why I like thinking of tree as more than a plant. It's almost like a historical document in this sense. Okay, before we go, I want to wrap up with one quick story that hits close to home with us being at UNC Chapel Hill. So, I want to tell you the story about how the most important discovery in the history of tree ring counting was also probably one of the biggest tragedies. It is the year of 1964. A geography student from UNC named Donald Curry is high up on Wheeler Peak in Nevada. He's looking for the Little Ice Age, and he finds this gnarled, weathered bristlecone pine. He starts to take a core sample, the standard, harmless way to count rings. But his stool gets stuck. Not just stuck, it snaps off inside the tree. Now, instead of walking away, he gets permission from the Forest Service to just cut the whole thing down. He hauls a slab of it back to his lab, puts it under a microscope, and starts counting. He counts to 1,000, then 2,000, then 4,000. He eventually hits 4,862 rings. In that moment, he realizes two things. First, he has discovered the oldest non-clonal living thing ever recorded on Earth. Second, he just killed it. The tree was named Prometheus, and his death changed everything. It provided a perfect 5,000-year ruler that scientists used to fix the math for radiocarbon dating, essentially rewriting human history books. It also sparked such an outcry that it led to the creation of what we know today as Great Basin National Park. So, the next time you're counting tree rings, remember Prometheus, a tree that had to die to teach us how much history can hold within one single trunk. Now, putting it all together, tree rings become a kind of life story. They show growth because the tree is constantly adding new layers. They show struggle because difficult conditions leave marks behind. And they show history because those rings can reveal things about the environment long after the year has passed. Every tree has its own story written inside of it. Some years are better than others, and the rings keep track of those changes. That is what makes dendrochronology so powerful. It lets us read the past in a living organism. So the next time you see a tree, I hope you think about how much more it may be telling us than just its age. Its rings are not only the signs of time, but they are signs of experience. Thank you very much.